Welcome back. This is a lecture video on section 7.1, which is 6.1 in your textbook. The chapter is on Newton's third law of motion. If you remember, there are three very important laws of motion that Newton came up with. Isaac Newton, English fellow, early 1700s, late 1600s, and he came up with three. The first one is the idea of inertia. An object in motion stays in motion. Object at rest stays at rest unless acted upon by an outside force. So the more mass you have, the more lazy it is to motion. The second law, remember, was expressed as a formula of force equals mass times acceleration. So in order to accelerate a mass, you must apply a force upon that mass, and that the force is directly related to the mass. So the more mass of the object, the more force required to accelerate that object. The third law is for every force, there's an equal and opposite force, or for every action, there's an equal and opposite reaction. So the first idea is the idea of interaction. All forces are part of an interaction. So you can't have a force on an object without that object also applying force back upon you. So if you were to hit the wall with your fist, don't do it, because the wall will hit you back exactly as hard as you hit it. A book resting on the table is going to, as long as that table is still standing, the table is exerting equal and opposite force of the weight of the book. If you were to weigh more than the table, say a book that would weigh more than the table could stand, then the book would accelerate through the table. The table would fall to pieces and the book would accelerate through the table. But as long as you have a support force, that's an opposite force. And equal and opposite, Newton's third law, is really how all things will move on the earth. You couldn't walk across the floor or bounce a ball or anything without equal and opposite forces. So in the simplest sense, a force is a push or a pull, and a mutual action is an interaction between one thing and another. So if you put a force on the wall is putting a force upon you. So let's look at some pictures. When you push on the wall pushes on you. Otherwise, you would accelerate through the wall. So as long as you are not moving, then the forces must be balanced. And so unless you have the strength to shove the wall over, the wall will support you and it will be equal to the force that you put on the wall. If you drive a nail with a hammer, the same amount of force is applied to the hammer at the nail head as the hammer is applying to the nail. Now the nail is smaller, and so the nail's mass is smaller, and the same force that the nail's applying to the hammer is applying to the nail, and that same force will accelerate the nail. It may bounce back the hammer. You may have a recoil, so you can have a recoil, say, with a gun. You shoot a shotgun, you're going to get some recoil. You can hit an insect on the windshield with exactly the same force as the insect is putting on your windscreen. But the problem is that same force is applied to both objects, but the insect, it destroys the insect, and it doesn't. That same amount of force doesn't destroy your windshield. So the hammer exerts a force on the nail and drives it into a board, and there is a force exerted on the hammer to halt the process. Otherwise, the hammer would go right through the board and right through the table and right through the ground. There must be some force coming back upon the hammer. So Newton reasoned that the hammer exerts a force on the nail exerts a force on the hammer. So here's the number one thing you need to get from this section. Every time that you have a force, you're going to have a pair of forces. One acting onto something, and then an equal and opposite force acting back on what is causing the force in the first place. So all forces act in pairs. That's the most important thing from there. There's always a pair of forces. So, does a stick of dynamite contain a force? So what do you think? Would a stick of dynamite contain a force? Is there a potential force in a stick of dynamite? Is it an exploding stick of dynamite causing a force? So the way that question is stated, the answer has to be no. So that a force is not something intrinsic, like density or color. A force is an interaction. So an exploding piece of dynamite may cause a force on something, and the force would be put back on the dynamite. So the dynamite may get hot and push on the air that's around that dynamite, or on the box that dynamite's in. But the box would push on that expanding gas exactly the same. So it's possible, as long as it's interacting, you would have a force. But there's no force intrinsic into that. That's why we will say that it has potential energy. That energy is the ability to do something, to push something, or to cause something to move. So why do forces always occur in pairs? If you think of forces as pushes, then you can't push something without interacting with that something. And the interaction is two sets of matter touching, or two sets of, say, the electrons around atoms, which are repelling each other. So there's mutual pushing. One is pushing on the other is pushing back. So all forces occur in pairs all the time.